the only thing you really need to know. So, the big emphasis on Chapter 8 is pretty much what you see on Section 8.3. Everything about being able to prove a particular identity is true, which is basically fundamental algebra skills. All right? If you're very good at being able to do all the problems in Section 8.3, then when it comes time for you guys to do it in calculus, it's not going to be that complicated. Because all those other ones, these are just other identities that you simply pile on to the identities that you already know. In other words, the problems that you're dealing with those in the particular book is no different than the problems that you're going to be doing in Section 8.3. So if you know how to do Section 8.3, no problem. Okay? That's the key to the whole
Can I
thing.
ask you something?
Go ahead.
So I was doing YouTube tutorials with Mr. True, do your homework. Love that guy. And he was saying that you can apply your algebraic skills to trigonometric identities, except you cannot work with the equal sign on both sides of the equation. You can
Well,
do it
he's
on
partially
one
true.
side.
He's partially true on that. Some people claim that you have to leave one side alone and simplify on the other side. Some people claim that that's not the case. And I'm telling you is that you can do either one. Okay? There is no rule that says that you have to work on only one side in order for you to make it look like the other side. You can work on both sides as long as you get one side making it look like the other side.
Okay.
Okay? Now, if you want to follow that practice where you just simply focus on just one side, you can. But you're going to come across problems where doing that, it's not necessarily impossible, it's just that it becomes more complicated.
Is it my perfume?
No.
That might be the Chuck.
No.
I'm still in the room with Chuck.
I know. No, it wasn't that.
Okay,
I was
whatever.
trying not to sneeze, actually.
Like I said, it might be Chuck.
Yeah, actually, now that you say, yeah, but I don't think so. And I've got my mask in the car. I can
All right,
bring it
well,
in if
don't
it's-
worry about it. If it gets to that point, we'll stop.
Okay.
All right?
Getting my stuff out of the way. I have nothing left to say, so.
All right, so that would be the focus. So, I mean, if you have a book out, I can show you exactly what, you can look at some of the problems here.
I'm gonna, do you mind if we share?
No, I don't mind at all.
So just turn to page 672. We'll look at those problems pretty much.
672.
My back's doing better. That was awful.
What happened to your back?
I'm not sure. I have this ongoing soft tissue thing that's
What do you do?
Well, I
ongoing.
did learn one interesting thing, medically speaking. Whenever, like, for example, if your arm hurts or something like that, like you feel like you pulled a muscle, what's the worst thing you can do? Not move it.
Yeah.
That's the worst thing you can do. The doctor tells me, no. People keep on thinking that when you get hurt, like you have a muscle pull, that you don't use the muscle and it will heal. No. If anything, it will make it worse. You have to keep moving it. You don't have to, like, lift like a ton truck or something like that.
No, when my massage therapist's shoulder froze, she
That's
kept
what they
moving
call
it.
it.
Yeah, she
Freezing
kept
the shoulder.
she kept moving it, and they did chiropractic on it, and it healed a lot faster than not doing anything.
Right. So
So
that's the rule. That's one thing I learned. All right.
she's also a math person, and she wants to take a class from you
Well, there you go.
because I
Okay,
brag about
so-
you all the time.
What I'm going to be focusing on right now is pretty much any one of those problems that you see on page 672.
Okay.
Okay? Any one of those problems on 672.
Okay.
So I guess I would like to focus on more is on the even number problems. Because,
Stop.
What's wrong?
She looked at the problems and said, "Oh my God." Shh.
All right, hold it. Before you start panicking, let me just tell you this. When you get a small little reprieve from your math work, where you are doing grueling work, you're going to have the feeling that you're having right now. Okay? All I'm going to do is I'm going to show you how to do these on the board, and that way later on you can be able to go over them when you have time to actually sit down and actually start from where you left off from the semester, so that way you can
And
look
practice.
and practice.
Okay.
Exactly. So don't get overwhelmed. It's not a big deal. I know what you're looking at right now is probably Swahili to you, but don't worry about it, okay? I'm not saying this directly to you, I'm telling both of you this.
No, I have.
I haven't looked
When
at the
you have a
problems.
break, exactly, this is what happens, when you have a break, when it's something that is rigorous, you will put it out of your mind until you absolutely positively need it. And right now, you don't absolutely positively need it, so that's why your brain is not working properly in terms of looking at it and saying, oh, I understand. Okay? A little bit of practice will rekindle that information that you had before, so don't get upset.
Yes, but you're assuming that even with the little bit you gave us in that
Don't-
one
don't-
10-point
just
question
don't.
that you gave us on the test,
Let's just
there were a
assume-
lot of us who knew how to
I am
get from
not
point A
going
to point B.
apologize for it.
I'm not asking you to apologize for it, but some of us, I'm looking at some of these questions going, I didn't even know how to get from point A to point B with just going over 8-1.
Trust the guy, don't
Ah.
ask, and suffer.
I recall someone saying that at some point.
I trust you, I'm just having to vent. You got to vent for half an hour about people not being here. I can't vent a little bit?
No, you can.
Okay.
Just remember that when you're venting, you're wasting time. All right. You see a lovely mess. What do you do with the lovely mess?
Okay, hold on. Can,
What you do with the lovely mess is you pick up some spick and span and you start cleaning.
I would say we do everything in sine or
There
cosine.
you go. That's not a bad idea to start off with. Now,
So you have to work with reciprocal.
let's say, for example, that we wanted to work on only one side. We're not, but let's say that we're only going to work on one side. Just one side. Which side would you work?
The right,
Right? Why the right?
because then,
Now imagine
No.
this. Now imagine this. Think about this. Your job, this is your job, to make the left-hand side and the right-hand
prove
side
it,
look
or
exactly the
we're
same.
verifying, so no left.
Right. If you're going to pick to see which one you're going to work with to make it look like the other side, always pick the side that looks more complicated than the other side. Okay? You pick the left, not the right. Okay? Now, this, these are not regular sines or cosines, are they?
No.
Okay, so the idea then is for us to actually work those versus anything else. Because if you sit down and actually think about all the different identities that we had, and I'm not asking you to look at it right now, okay? None of them involve just a regular sine plus cosine.
I have a serious question to ask you.
That's a serious question.
So, with the Pythagorean theorem of sine squared x plus cosine squared x equals 1, and then you have sine x, and how does that work with canceling out a
You can't use the Pythagorean theorem in order for you to cancel out to make it just sine. What will involve is a radical, and that gives you a bigger mess.
Because I heard you can cancel out factors, but,
You can cancel out factors, but not terms.
okay.
If I wanted to solve for just simply sine, this is essentially what would happen. Okay, I'd have to bring a cosine onto the other side, right? And then to get just sine, I would have to take the square root of both sides.
Yeah.
So that would give me this. Square. Okay, see that? That's what you would get. Do you want me to complicate it even more? I
Yeah,
haven't even
yes.
discussed plus or minus.
Yes, please go, because
You understand? This is the reason why
Yeah.
this, not a good idea
yeah.
when it comes to doing verifying. Unless, in the problem, there's a radical somewhere. Now, if
Okay.
you notice in the problem, is there a radical?
No.
No, so this is just,
So this is just, that's not going to help matters. Yes, you could do that, but that does not help. Okay?
The denominator, could the denominator be 1 over,
Exactly, it will be that. 1 over cosine.
plus 1 over
Plus
sine?
1 over sine. Okay. The problem is we don't really have a lot of room in the board, which is unfortunate. So I might have to do some erasing. Okay? This
See, that was the only one I actually
is
know.
one way of actually working this. Now remember that I just said it's only one way. It's not the way, it's one way.
hold on.
I'm not gonna go fast.
Oh, you pushed me to my very best,
That's my job.
and I love you for it.
Yes.
So,
What do you think you
I'm
need to
not
do
laughing
here?
at I'm not laughing at the sentiment, I'm just, anyway.
Relax. Relax.
Okay.
No.
okay, what you need to
can
do
cancel.
is, no.
Can't
No.
cancel.
Can't cancel?
Reciprocal.
Not yet.
You just
Not
multiply.
yet. Not yet. I know what you're thinking. You're not wrong, but not yet. What do you have to do first? You can't take the reciprocal until you have a singular term in the denominator. We do not have a singular term yet in the denominator. Okay?
You multiply the, you multiply.
Hey!
Hello,
You're only an hour and 10 minutes late.
sorry. Family issues.
Sit down.
Happy New Year.
Happy New Year. Okay. You cannot do the reciprocal yet because you need a single term.
Okay.
Okay? So we have to then do this. Two fractions, different denominators, means find LCD, least common denominator.
So you're gonna have cosinus x, sinus x, cosinus x, sinus x. Two
Cosine x,
cosinus.
sine x, cosine x, sine x. Oh, and I put one there.
You and Nina both forgot your writing instruments.
I have a crazy family.
That's okay, I'm teasing.
Remember that feeling you had when you just opened the book and look at all the trig functions? You said, oh my. This, by the way, is the same reason why you guys did not bring your writing utensils, because you're not in school mode. Your mind is not in school mode, and that's why. So it's okay.
Okay. Hold on, I'm still looking.
Don't worry about it.
What page are we in?
On
672.
So you have two.
Right, so I'm finding the least common denominator of both of these. I found it. This is it.
Yeah.
Now to transform this into this, right?
Mm-hmm,
I
gotcha.
have to multiply this with sine to get this,
Sine
right?
x.
So
That's
that's,
sine x. Okay.
oh, okay. And that's cosine x.
On this one,
It's
to
cosine.
get from here to here,
So you use cosine. So,
Cosine.
so you basically use the fancy one.
so to speak, not really, but it's better for us to say it as least common denominator.
Okay.
Fancy one involves something else when you're rationalizing or
Can I-
doing, go ahead, rationalizing or something.
To get this. To get this, you basically just did this.
Oh, okay, I see what you're getting at.
I have problems with
It's not really a fancy one, but you're
because
just
of my
trying to figure out what's the
fibromyalgia,
missing
sometimes I
factor
can't
from here
stand
to
things
here.
on my legs.
And the missing
so
factor is sine.
I actually will
And then
drive
you
like
multiply
this.
the bottom by
you
sine,
know.
you multiply the top by sine. So I guess you
Yes,
could
I
think
get
of it as
cold,
fancy
but I
one.
will drive like this
Yeah.
because I just can't
Alright,
stand
then.
having things on my
That's fine.
legs.
With radical.
That works?
So-
It works.
That's
Oh, I like this.
No, that's okay. It's just, it doesn't hurt, it just itches.
Oh, good. Can I scratch it?
No, because it won't help.
Kidding.
All right, now that we have two fractions,
We're a weird bunch.
I love it. But hold on, don't erase.
I'm not erasing anything. I will tell you when I erase, okay?
Alright, so
Now that we have two fractions, same denominator, we built them up. Now I'm going to take these two fractions and merge them together.
wait.
I'm waiting.
So it's sine x plus cosine over cosine x sine x.
And here we did. Jesus, Nick.
I once again say this, I will not apologize for anything.
No one's asking you to.
No one asked you to
We don't-
apologize for that 10-point question either.
So,
Which one was that one?
so okay. Oh wait, wait,
The
wait,
one he
wait.
knows that I
Don't
couldn't
worry,
get
I'm
from
not
point A
moving.
to point B.
Ollie, you see those right over there? The list of things over there? Those are the pieces that are considered to be important in Chapter 8 that we did not discuss,
Okay.
okay? Later on, we'll talk about each one of them, but I want to first work on this a little bit before we actually talk
Yes.
about those.
Let me catch up with my work. So, I can at least
I would've
have a
went to my office.
stab at you because I know that you're bored with us,
Did she just say that she was gonna stab me?
with us
Who?
cleaning the blackboards and, I'm
Yeah,
just kidding.
well.
Oh, but
But
they've already asked
please
me
pass
about.
me the broom so I can ride it home.
No. All right.
I didn't know we had a which now
It's terrible. So, okay, and this still
No
equals.
comment.
Oh, you guys think I'm a
No,
no,
we did
you
not
made
say
the broom
that.
comment.
You're the one that made the broom comment.
Well, it was nice. I thought you guys would like that,
I did like it.
but I
All
won't
right.
use it in class.
Can I erase this?
Yes, I will them that.
No snack for me.
Now,
Yeah, she didn't bring snacks for everybody else. It's a joke.
All
so,
right.
these two combined together, we will get this.
So we're just simplifying.
Pretty much.
No,
So
yeah,
now, can you cancel?
wait.
So think of this as stage 1, stage 2, stage 3.
Hold on. Stage, that's what I wrote. Stage 1.
2 and 3.
Well, this is 2. 1. No, this is 1. Okay. Make denominator singular. Okay.
You see that now?
And number 3.
Okay. What this is now getting close to is this, if you notice. We can go back. We had a numerator with 2 terms, a denominator with 2 terms. Down here we have a numerator with 2 terms, a denominator with 2 terms. Now over here we have a numerator with 2 terms and a denominator without only 1 term, just a single fraction. Okay? Now this stage is where we actually use the thing that you were talking about, which is the reciprocal. Now you're doing your flip. So in stage 4, what you're doing is you're flipping. You're rewriting this horizontally. What I did in stage 4 is I just rewrote stage 3. All I did was write it horizontally. I did not write it vertically. Stage 3 hasn't written as vertically. I wrote it horizontally. Okay? That's all I did. Now this is not really necessary to some people. Some people just want to go right for the flip.
How about brackets around, it's just European brackets around, no, the other side?
This one?
Yes.
This. All right. You want to do it that way? Okay.
Have you noticed my tendency to use brackets in my work?
That's fine.
It's crazy.
But why?
Whatever
would you-
helps.
Okay, I just was wondering if there was a.
Brackets, it doesn't matter.
Well,
Put
I
it in,
bracket
don't put it
everything
in,
too,
doesn't
but-
help. I mean,
Okay.
it's not that it doesn't help, it doesn't matter.
Okay.
It's still the same thing.
Okay.
By writing it horizontally, then we would simply then do the reciprocal, the flipping, as it were. Okay. We do the flipping.
Okay.
See the flipping?
Oh. Now it's multiple, okay.
Now we flipped it, so we did the multiplying. Now, this time we put square brackets around it.
Okay.
This now get canceled with that.
Whole,
It can cancel the whole thing, because if you look at it, sine x plus cosine x. Down here, it's sine x plus cosine x. Okay, we can simply cross this out, and in stage 6, what you have left is this, cosine x, sine x.
Okay,
Go ahead.
why?
Why are we crossing them out?
Why are you able to cancel out?
Because it's the same thing.
Not because, is there an imaginary 1 under, you're not?
Yes, you can think of this as a singular fraction if you so desire with a 1 underneath.
That's what he refers to as training.
I know, it's not training wheels, it's.
Actually, it is training wheels.
Okay,
When he's referring to that in class, that's what he's referring to when he
no,
does
I
that.
know, I'm
Okay.
I'm confused, when you have sine squared, and then you have sine, you can't cancel that out.
This is the same thing over here.
So when you have sine squared, and then you have sine, and then, okay, sine squared in the numerator, sine in the denominator. It does
If all
not-
you had sine squared in the numerator and the denominator only had sine, you can cancel it.
You can?
You can. If you have sine squared x plus 1 and the sign on the bottom, you can cancel.
Okay,
Okay? This.
So there's a plus.
If you have
It's like
this-
6/3.
If you have this, you can cancel. Okay? You can cancel it to just say sine.
But we still have sign on top, yeah?
You still
Yes,
have the
okay.
sign. You can cancel.
Yeah.
However, this, you can't cancel.
Did you get
Okay.
that, David?
The difference is the top one is basically a bunch of factors. Okay, this one
Yes.
is a bunch of factors. This is a factor, this is a factor.
okay.
Two signs multiplied together, they're factors.
Yes.
Down here, this cannot be a factor because it's being added to something. And because it's being added to something, it's no longer factors, they're terms.
Okay,
Okay? The only time that you can cancel this top one right here is if the bottom one is exactly the same. That's
if
the
it
only
said
time.
plus 1 as well.
Yeah, and also this has to be sine squared as well. Okay?
Okay,
Now over here, we can cancel because you're canceling the entire thing with this entire thing. That's why we can cancel, and over there we can't.
thank you.
Okay. That's all right. That's how we get it.
So it was training wheels, but maybe a little bit of,
More complicated training wheels.
oh, no, you took the training wheels off and you're holding the back of the seat and saying, you can do it. You can do it.
You guys, when you learn how to drive, you have like the you know, they have these special cars where the passenger side has a brake.
Yeah.
Those are the advanced training wheels, where the
Okay.
guy has a brake. Those are the advanced training wheels. All right. Anyway, where have we gone with all of this? Well, all this means from here, 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 here. Now we have this.
Verify.
If you recall, each one of these, when we were doing this, we're making the assumption that they equal this little mess over here.
Right.
Now, I didn't write it every single time because I needed the space. But essentially, each time I made it equal to sine x over secant x, sine x over secant x in each one of those. Okay, so in other words, we have willed this down. Now I have to erase. Is that okay?
Mm-hmm.
Can I erase these three?
Go for it.
All right.
Just gonna make sure my equipment's out.
So we whittled this down to this. Okay?
I'm just, I'm obsessive. I know it's 3, but I've waited like months.
That's why I'm not going to make you lose it. Don't worry.
Sorry, Jennifer, need to make it Tuesday at 3. Will that work? Yes, okay.
All
Today is Tuesday,
Yeah.
Yes, it is.
so,
Don't worry. You'll leave in an hour. All right. Everybody see this?
Mm-hmm.
We have whittled it down to this. Now, we still need to make this side look like this side.
okay. So that's
Okay?
step 7.
Well, okay. Actually, it's more like 6. I just didn't write it. You know, look. It's more like 6. I just didn't write that other part.
Okay.
But if you want to make that step 7, you can. All right?
Mm,
We still, however, need to make this side look like this side. Any ideas?
Reciprocal.
Here, you mean?
Yeah.
Okay. Well, here's the thing about making this a reciprocal.
Then use a reciprocal, then Pythagorean.
Well, hold on, don't rush it.
Why can't,
Watch closely. What is secant?
One
it's one
over
over,
cosine.
1 over cosine. Correct?
Multiplied.
Now, if I just do the flip then, right?
Yes.
Okay. I'll get this. Correct?
Yeah.
And then sine x, cosine x, isn't that the same thing over here? Sine x, cosine
Verify.
x? You're done. Okay.
couldn't you have just done it on the other side? Just continue working on the other
You
side?
could have done it any different ways. That's the thing
Okay.
that I was trying to get you guys to understand. That I just went one way. There are infinite ways for us to actually go in order for us to
That's
get to
what
the
it
answer.
says. The answers may vary.
Answers may vary. There's a reason why they say answers may vary, because there's an infinite amount of solutions. Notice that over here, if I just simply did this and divided this entire thing by secant,
No.
Right?
I would have gotten this. Maybe, maybe not. The point is what do you do in order for you to make this side to look like that side? Since we were trying to get everything to look like sine and cosine, the only inclination we had was to change this. We could have just as easily multiplied both sides by secant, couldn't we?
I thought we were trying to make everything
I
look
like
like
to do
sine
things
x
pretty
over,
and clear.
secant x.
You can, that's the point. There's so many
Okay.
different ways for us to approach it.
Okay.
If we multiply both sides by
No,
secant,
there's just mine, because my name is Hitler, that's it.
I'm not Hitler.
No.
No, I'm not Hitler. So, if I multiply both sides by secant, all right, I would have had secant x, cosine x, sine x.
Mhm.
The secant x and the cosine x would have canceled each other. And then I would have just simply had sine equals sine.
That means you have a lot of time on Sunday to practice with these extra functions.
The point I'm trying to make is that the best way for you to be able to do this